Okay, so now, as we discussed in the previous video, we had three different. When you have basically at the end of the day a system of linear equations in two variables is basically at the end of the day it's basically two straight lines in a plane, and we said that any two straight lines in a plane, if you imagine having that sort of situation, there are at most three different possibilities for these two straight lines. So these two straight lines could intersect one another, as we said in the previous video, like this, or they could be parallel, or they could be coincident, meaning that the two lines could be actually one. Basically, the two lines could be equivalent lines, and that means that basically we would actually be talking about the exact same lines. So now we are going to talk about three typical situations in which these three phenomena basically happen, and then we will take it from there. Okay, so there is a situation number one. There is a situation number one, and that's basically, let me see if I have enough space over here. Seems to be so. Or let me actually use a different sheet for each of these situations, because I'm going to need to come back to these. So let's say that you have situation number one, and what that is that basically the problem that we want to solve here. So basically John wanted to play video games, so he went to one of those places where kids go and play video games. I don't know what they're called, but he went to one of those big salons, or whatever you call them, to play video games. Now there were of course many different types of games you could imagine over there that he could play, but he wanted to play particularly two different types of games, and let's call them for example game type A and game type B, for example. Okay, so he wanted to play these two particular games, and now basically the information about how he played those games is that the number of times John played game A was half the number of times he played game B. So number one, so the number of times John played game A was half the number of times he played game B. Okay, so what this algebraically means, if I want to be consistent in what I'm saying, so I have to keep going back to my notes, otherwise things will fall apart. And let me actually write the other condition as well. So he had to pay basically $4 for each for each time he played game A, and he had to pay he played game A and $3 each time he played game B, and $3 for each time he played game B. Okay. And he paid $20 in total. In total he paid $20. Okay. Now you want to find out the number of times John played game A and B. Game A and game B. Okay. So now in this situation, what I want to do first, I want to express these sentences in a mathematical way, or in algebraic way, in an algebraic way. So what I can do is that this was page 4. So what I can do is that I can take the number of times John played game A, the number of times John played game A as as Y. I have taken it Y over here. You could take it X or Y. It doesn't really matter what you do, as long as you know what you've done. But since I have basically put together these notes in this particular way, I cannot change it, otherwise other things will be affected. Okay. So I take here Y as the number of times John played game A. Okay. And then I take X as the number of times John played game B. This way I can do a couple of things with, I can write these sentences in an algebraic way. So if I do that, so the number of times John played game A, which is basically Y, was equal to 1/2 of the number of times he played game B. The number of times he played game B was X, so 1/2 of that would be 1/2 X. And then for each time he played game A, he paid $4. For each time he played game B, he paid $3, and in total he paid $20. So if I imagine that he played game A a Y number of times, so he played game A Y number of times, and also he played game B an X number of times, and in total he had to pay basically $20. Okay. And moreover, each time that he played game A, he had to pay $4. So game A was over here again taken as Y, so I write this as 4Y, meaning that if you play game A one time, that would be basically Y is equal to 1, then 1 times 4 is equal to $4. 2 times would be $8, and so on and so forth. And each time he played game B, he had to pay $3. So game B was denoted by X, so 3X. So that would be 4Y plus 3X is equal to 20. So now these two linear equations, each of them represents the situation that we are talking about John, that he played these two different types of games. So I can write this as Y is equal to 1/2 X, and Y and 4Y plus 3X is equal to 20. Now these two equations taken together is called a pair of is called a pair of linear equations in two variables. And you already know the reason why, because both of them are about the same situation, and you have the same two variables in both of the equations, and moreover you have both of these variables are actually representing the same thing, the same phenomenon, meaning that x is consistently representing the number of times he played game B, y is representing the number of times he played game A, and so on and so forth. And there was one more thing that I don't remember exactly right now, but you can call this system of equations a pair of linear equations in two variables. And now if you can solve this system of equations, you will be able to find out what x was and what y was, and you know that x represents the number of times he played, for example, game A or B, and A or B, and so on and so forth. So then, long story short, at the end of the day, you will be able to find out the number of times he played game A and game B. Okay? And of course, there is an E over here. I forgot to write that. So now the interesting thing here is that basically, now let me rewrite these equations in the general form. In the general form, you would write this as 1/2 x. You would write this as 1/2 x and take y to the other side minus y is equal to 0. And then you can multiply everything by 2. You will get x minus 2y actually. X minus 2y is equal to 0. And that would be this equation over here. And the other equation would be 4y plus 3x is equal to 20. So the only thing that you need to do, I just write x first, so 3x plus 4y, and take 20 to the other side, minus 20 is equal to 0. So this is the equation in general form, and this is the other equation in general form. Okay? Now, the interesting thing here is that each of these equations, taken alone, has an infinite number of solutions. Meaning that, for example, if you draw this line over here, this would be, for example, x minus 2y is equal to 0, so minus 2y, negative 2y is equal to negative x, and 2y is equal to x, and y is equal to 1/2 x, right? So y is equal to 1/2 x would be something like this. It would be a line that goes through the origin and then so that would be your line over here. So you would have a straight line like this, okay, and these are the 2 points going through, basically related to your line. This is your y and this is your x. So you see that and as we discussed before, every point on this line is of course a solution to this equation, meaning that, for example, if you take this line, this point over here, it's 2, 1. Or if you take this point over here, it's 0, 0. And if I put 0, 0 in this equation, I get 0 is equal to 1/2 times 0. And 0 is equal to 0. This is a solution. Or 2, 1, or basically y is equal to 1 here, so 1 is equal to 1/2 times 2, 1/2 times 2, and 1 is equal to 1, and that's also a solution. So any point that you pick on this line is going to be a solution to this equation. And so you can say that this equation has infinitely many solutions taken basically alone, not with the other, not with the other equation. Now, but again, so this line over here is basically x minus 2y is equal to 0, okay? Now, the other line over here, 3x plus 4y minus 20 is equal to 0. You can write it as 4y is equal to minus 3x plus 20. And then you could write this as y is equal to negative 3/4 x plus 5. And then you would have essentially some line over here. There is something called the y-intercept. That means that the point where the line goes through the y-axis, that would be way up here at 50, and then the slope of the line would be negative 3/4 in a negative slope, so that would be a negative slope, which means that you would have 1, 2, 3, 1, 2, 3, and 4. So your line would be something like this. Of course, it's just an approximation, but you would get some line like this. I could actually do the exact basically graph of the line, but it's not important right now. The important thing is that again you will have this line over here, and this line taken alone will have an infinite number of solutions over here. All the points that you could find on this line are actually solutions to this equation. But now there is a point over here, somewhere over here, that the two lines actually intersect, and that point is the point of intersection of the two lines, meaning that point lies basically on this line and also on the other line, meaning that point satisfies both of those equations. And that's basically the key here. If there is a point that satisfies both of those equations, that's basically what the solution here is, which tells you about the number of times John played game A and game B. The x coordinate of this point, the point of intersection, whatever that might be, there would be x1 and y1 over here. x1 tells you about the number of times he played game B, and y1 tells you about the number of times John played game A. And that's basically the whole story here. So you can imagine that this pair of linear equations has one and only one basically solution over here, and that solution is basically one single point. Now we could actually go over here and do the graph of the function and see exactly what that looks like. So let me actually make a screenshot over here, and we will go over to the graph and I'll show you what that actually means. So I write this as y is equal to 1/2 x, which is basically this line over here. As you can see, the slope of this line is actually half. You see over here you have 4 horizontal units for 2 vertical units. So we call this the run over, and we call this height, we call it the rise. So rise over run, which means 2 divided by 4, is going to be the slope of the function. 2 over 4 is equal to 1 over 2. That's the slope of the function. or basically the graph. So that's basically your first line. The second line that you have over here is 4y plus 3x is equal to 20. And you see that, and this is the second line over here, and you see that the slope is actually negative, as we kind of predicted as we were solving that exercise, that situation number 1. So you see that the line is this blue line over here, the other line is this red line, and there is a point of intersection which is 4, 2. Okay, so that means that this point 4, 2 lies on this blue line, and it also lies on the red line. Okay, so that means that this point satisfies both the equations representing both of these two lines. Okay, and that's basically your solution over here. So now let me erase all of these things. Okay, so now let me erase all of these things, and I will do a very simple graph over here. So let's say that you have 1, 2, 3, 4, 1 and 2, and this will be basically this will be one of your lines, and this will be somehow the other line over here, and this point over here 4, 2 is the point of intersection. Of course, this graph is in no way accurate or anything, but I just want to show the solution over here. So this is basically your solution. Now if you use this solution in any of these equations, you will see that this solution actually satisfies both of these equations, meaning that 4, 2, and so y is equal to 1/2 x. So if you substitute this point in this equation, you'll get 2 is equal to 1/2 times x, which is equal to 4, and so 2 is equal to 2, which means that this point actually satisfies this equation up here. Moreover, if you have the same point 4, 2, and if you have 4y plus 3x is equal to 20, if you substitute this point in this equation, you'll get 4 times 2 plus 3 times 4 is equal to 20, and we can verify 8 plus 12 is actually equal to 20. 20 is equal to 20. So that's the point satisfies this equation as well. So then you can say that this point is actually the solution of this pair of linear equations in two variables. Okay, so then what you can say about this whole situation is that basically 4, 2 is the solution of this pair of linear equations. So that means that your x is equal to 4 and y is equal to 2, right? So now what that means is that x was the number of times that John played game B, right? X was the number of times that John played game B. So that means that John played game B basically X times or 4 times, and also John played game A 2 times. Okay, and let's see if that actually makes sense in the case of the information that we have here. So we said that the number of times John played game A was half the number of times he played game B. So the number of times he played game B was 4 times. Half times 4 is equal to 2, which is correct. And we said that he played a number of, he played game A a number of times, he played game B a number of times, and in total he paid basically $20. So if he played game A 2 times, right? So and each time he paid basically $4. So 2 times 4 is equal to 8. So 8 he paid over there, and then he played game B 4 times, and each time he paid $3. So that's $12, and so in total he paid $20, which is the same thing as what we said over here. So that is basically that is basically this whole situation over here. Okay. Now, there is a couple of things that we can still say about this situation. I'm going to erase all of this. I don't want to make it too crowded, but there is still a couple of things that we can say about this situation. But I'm going to hold them until I have talked about another concept, and then we will come back to this situation and we will talk about those as well. So in the next video, I will talk about I don't know, or let's do it over here as well. There is no problem with that. Okay, so now there is another situation that we can consider, and that is basically situation number 2. So let's say that you have, the situation is basically like this. So Susan, for example, let's say Susan bought 2 pencils and 3 erasers. 2 pencils and 3 erasers for $9. And her friend Sarah bought 4 pencils and 6 erasers. 4 pencils and 6 erasers for $18. And remember that we are talking about the same pencils and the same pencils and erasers of the exact same type, having the exact same unit price. Okay, so we are actually talking about the exact same types of pencils and erasers. And now what we want to basically figure out here is what was the price, what was the unit price pencils and erasers. That's basically what we want to answer here. So let me actually take a few minutes rest, and I'll be back with you with the rest of this. Okay, so now in order to basically solve this problem, so I will take this as a solution. I will take the price of basically one pencil as X, and I take the price of one eraser as Y. Okay, so if I do, and basically if I do so, I will have basically I can write two equations for these two sentences over here. So basically I know that Susan bought 3 pencils and 3 erasers. So or actually you can what you can do is that if I take X as okay, so if I take X as the price of one pencil, or the unit price of one pencil, so then the unit price of 3 pencils would be 3 times X, and the unit price of 3 erasers would be 3Y. Actually, this is supposed to be 2 pencils. I'm sorry. So this is supposed to be 2 pencils. So 2 pencils. So then you have basically 2X plus 3Y is going to be equal to $9 he paid in total. And then what Sarah did was that he bought basically 4 pencils and 6 erasers for $18. So if the unit price of pencils is basically X, so then the price of 4 pencils would be 4X, and then the price of basically 6 erasers would be 6Y, right? And she paid $18. So I take this as equation 1 and 2. So now that I have these two equations, I can call these two equations as a pair of linear equations. in 2 variables. And the way that I can solve them is that I can draw let me actually do this in a different way, or well basically I have 2x plus 3y. 2x plus 3y is equal to 9. So I have to separate my y over here. So 3y is equal to negative 2x plus 9, and y is equal to negative 2/3 x plus 3. Okay, so this is one of my equations, and the other one is 4x plus 6y is equal to 18. So 6y is equal to minus 4x plus 18. So y is equal to negative 4 by 6x plus plus a 3, right? So now I have taken these two equations and I got these two equations. So, and I basically changed the form of the equations so I could draw the graph of these equations. So they are y is equal to negative 2/3 x plus 3, which I got from 1, and from 2 what I got was y is equal to negative 4/6 x plus 3. I'm going to erase all of this, and what I'm going to do now is basically these two equations, and what I'm going to do now, I can draw this line over here. So the y-intercept of this line is going, of course we are going to get into the point where we are going to talk formally about the y-intercept and the slope. But for now, for the sake of simplicity, it's enough to know that when you have some equation like y is equal to, for example, ax plus b, this b over here is called the y-intercept. It's called the y-intercept, and this a over here is called the slope of this line. And the slope of this line is very simply, well, the slope of the line. I mean, for example, you can see that for example, this line over here is a little bit steeper than this line over here, and this line over here is a little bit steeper than this one. So this basically steepness of the line is called the slope of the line. And then what we have here is the y-intercept of the line, which is basically where the line goes through the y-axis. For example, if the line is something like this point over here where the line crosses the y-axis is called the y-intercept. The y-intercept of that line. And if you write your lines in this form, y is equal to ax plus b, then this constant is going to be your y-intercept. This number over here is going to be your slope. Okay. So what that means again is that basically when you want to draw a line, you don't, I mean, if you're not doing it on a graph paper or something like that, you don't want it to be very accurate. You can just do you can do it quickly by noting the y-intercept over here, which is equal to 3, for example, here 1, 2, and 3, and your slope over here is negative 2/3, meaning that, and remember that basically when you have negative 2/3, for example, this is called, the number in the numerator is called the rise, and the number in the denominator is called the run. So, and for the same reason, the slope of a line is given as the rise over the run. And I'm going to tell you what that means shortly. So what that means is that the rise over the run of this line is going to be is negative 2/3. What that means is that if based on this point that I know to be on this line, I can figure out where some other point is, or where the next point is, probably I could say based on the rise over the run of the line, meaning that what this means is that the run refers to how much horizontally you're moving along the x-axis, and the rise is basically how much you're moving vertically along the y-axis. So along the y-axis you're rising or falling, and along the vertical axis along the horizontal axis you're actually moving horizontally to the right or left. So horizontal movement is called run, and vertical movement is called rise. Okay. Now, for example, if your rise is towards the top of the coordinate system, it's positive. If it's towards the bottom of the coordinate system, is negative. If your run is towards the right of the coordinate system, it's positive. If it's towards the left of the coordinate system, it's negative. And that's basically how the slope of a line basically works. So now what that means is that for 3 units of run, you have -2 units of rise. So for 3 units of run, so 1, 2, and 3, and the point is over here. So that means that for 3 units of run, I would be over here. So 1 unit, 2 units, 3 units. I have -2 units of rise. That means that I have to come down 2 units. That means that I'll end up over here. So the other point, another point on the graph of this line is actually basically this point over here. And then if you connected these points together, you'll get the graph of this line, which is of course a straight line. Now, if you actually paid attention to basically this whole story over here, let me erase all of this. If you paid attention to the whole story here, now I know that 0,3, for example, this point over here, 0,3 is one point on this line, and this point over here, which is 3,1, is also another point on this line. And if I took this number 1 over here, which is y is equal to -2/3 x plus 3, and if I basically tried any of these points, they will satisfy this equation, meaning that 0,3 over here would give me 3 is equal to -2/3 times 0 plus 3. So this is 0, so 3 is equal to 3. Okay, and the other point will also satisfy this equation. Now this is all good. This is all good. So I basically have this line which is related to, I call it 1, for example, because it's related to this number 1 over here. Now number 2 is y is equal to -4/6 x plus 3. So y is equal to -4/6 x plus 3. Okay, so that means that the y-intercept here is again the same point, and my slope is -4/6. That is my slope. So that means that then this is your run, this is your rise. That means that for let's say for 6 units of run, you have -4 units of rise. So let's do 6 units of run over here. So 1, 2, 3, 4, 5, and 6, and -4 units of rise. That would be somewhere over here. That means that if I started at this point, and if I ran for 6 units, I would end up 1, 2, 3, 4, 5, 6. I would end up somewhere over here. And then for that amount of run, I have -4 units of rise. So that means 4 units going downwards. So 1, 2, and 3, and 4, and I would end up somewhere over here. Now, of course, it's supposed to be on the same line. So that means that the line is going to be actually this line over here. So you see, I end up actually these are supposed to be the same lines actually, right? These are supposed to be the same lines, and what that means is that I will actually end up with the exact same lines over here, meaning that these two lines are actually equivalent. And you can see it from here as well, meaning that if I write y is equal to negative 2/3 x plus 3 and y is equal to negative 4/6 x plus 3, so y is the same thing between the two lines, the y-intercepts are the same, and if you divided both the numerator and denominator, if you simplified this fraction, you would get divided by 2 divided by 2 3. It's the same thing. Y is equal to negative 2/3 x plus 3. Y is equal to negative 2/3 x plus 3. The two lines are actually equivalent. Okay. So that's basically and equivalent, and so you can see that the two lines are coincident. The two lines are coincident. Now in this situation, if you look for common points on the graph of the two lines, you will actually, what you will find is an infinite number of common points, because every point that you see over here is common to both the lines, because both the lines are actually coincident or equivalent lines. So that means that this pair of linear equations has infinitely many solutions. Whatever point you go, basically if you move from negative infinity all the way to positive infinity, all of these points are going to be common between these two lines. So therefore you can say that this pair of linear equations has infinitely many solutions. Okay. And then that's basically that was basically situation number 2. That was basically situation number 2. Then we call this situation number 2, and then we have one more situation over here. Situation number 2. And then we have one more situation over here. And what that is situation number 3. Situation number 3, which is something like this. So in situation number 3, you basically have two rails. Basically, you can imagine that something like a railroad, related to a train or something, right? So basically, two rails have been represented by these two equations. So x plus 2y minus 4 is equal to 0, number 1, and 2x plus 4y minus 12 is equal to 0, number 2, and this is the equation of the equations of two rails. Okay. Now let's try to draw these lines as well, and let's see what we get. And and I want to do them as neatly as possible, but no, it's not really important right now. So I will draw these coordinates of this coordinate system over here, and then I'll take 1 over here, and x plus 2y minus 4 is equal to 0, 2y is equal to negative x plus 4, so y is equal to 1/2 x plus 2, that's number 1, and number 2 gives me 2x plus 4y minus 12 is equal to 0, so 4y is equal to negative 2x plus 12. Y is equal to negative 2x plus 12, and y is equal to, so negative 2 divided by 4 is negative 1/2 x, negative 1/2 x, and 12 divided by 4 is equal to 3, so plus 3. That's number 2, and that is number 1. Okay, so if you simplify these two equations, you will get basically these two. Change the form of these equations. So negative 1/2 x plus 2, and the other equation would be y is equal to negative 1/2 x plus 3. Okay, so so then how you can actually you can basically draw these two lines. I call it, for example, 1-A and 1-B. 2-A. Okay, so so then this line would be y is equal to negative 1/2 x plus 2. You see, this is your y-intercept, so that's basically positive 2 for this line, and negative 1/2 is your slope. So what that means is that for 2 units of run, you have negative 1 units of rise. So I run for 2 units, I get over here, and then I have negative 1 unit of rise, so I end up over here. And then that's going to be one. Basically, you can call it 1 or 1-A because they are basically the same equations. And if you have this line over here, the y-intercept is 3, so this is 1 point, and then the slope is negative 1/2. So for 2 units of run, so 2 units of run over here, I have negative 1 units of rise, so the other point would be over here. So basically I'll end up with, so this is number 2, and so you see that the two lines, never intersect, they are parallel. Therefore, the pair of linear equations has no common solution that is, they have no solution. Okay, that is, they have no solution, and that's basically situation number 3. Okay, now in the next video there is something else that we need to know about, that we need to know about these three situations. We will talk about them, and then we will get to the rest of our stuff over here. I'll see you in the next video. Thank you.